now that you understand what the difference is between a lab and a field test, take a second and think about what are all the pros of doing a lab test. Now, when I ask your peers this same question, the most common response is that it's controlled, and that's a pro of doing a lab test. You're able to control the protocol very closely because you're right there. You can ensure adherence to the correct protocol. The environmental conditions are controlled. Importantly, it makes it very easy for you to collect data in a lot of regards because the person is right there stationary. So it's not like they're out on a track and they're running in circles and they could be 100 yards away from you at any given point. So it makes collection of information quite simple in that case. So then you have to consider, is lab testing always the best option whenever you're working with clients? So in order to be able to consider the answer to that, what are some of the pros of doing field testing? Now, the most common answer that your peers give for this question is that it's just more natural. There is a lot of things that are not natural about doing lab testing. Think about just white coat syndrome and taking blood pressures. So just the fact that you're in a more clinical setting with people observing you and they're right up in your personal space, right away that could change some of your physiological responses to exercise. It could affect your motivation to do exercise, either in a good or in a bad way. So field testing can be really helpful, one, because it keeps people potentially in a natural environment. Two, you can test individuals, and I mean a lot of individuals all at one time. So it's not like lab testing where you can usually only test one person at a time. Now you do have that negative of the fact that, well, the environment can work against you. Let's say it's raining that day and they're supposed to exercise, and that could be problematic. But in a lot of cases, field testing can be your friend, and you can get a lot of really valuable data from field testing. So don't think just because it's field testing, it's not as good or as valuable as lab testing. Field testing has its time and place for cardiorespiratory fitness assessment. One of the first cardiorespiratory fitness field tests that you'll get to complete is the 1 mile walk test. And the first thing I want to point out here is please do not memorize this equation. You have it in your lab materials, and this isn't the type of equation that you would use on a regular basis. What's great about the Rockport 1 mile walk test is that it can accommodate individuals of various ages as well as various fitness levels. However, I'll point out for an individual who is highly fit, we would recommend a different test other than the Rockport walk test that has that person exercising at higher intensities. The Rockport 1 mile walk test is a lower intensity cardiorespiratory fitness test. You want the individual to walk as fast as possible. So this means you're not gabbing with your friends or family as you're walking that 1 mile. And you want to make sure someone's walking and not progressing to a run. The individual then needs to measure their heart rate at the end of the mile. So in addition to the heart rate value, they'll also plug in their weight, their age, their sex, as well as the time it took them to walk the 1 mile. Generally, this test is pretty accurate, and it will estimate the correct VO2 max plus or minus about 5 milliliters per kilogram per minute, which isn't too shabby whenever you're not using any fancy lab equipment. Now, as I mentioned before, the walking test wouldn't be ideal for someone who has a higher cardiorespiratory fitness that you're aware of, so a jog or run test may be more appropriate. There are 2 different ways that you can administer this test. You can ask someone to jog/run as far as they can in 12 minutes, or you can specifically have them run 1.5 miles and calculate what the time was that it took them to do that effort. This is one of the more common ways to assess for cardiorespiratory fitness, particularly when you're administering that to many people at once, because you can have them all running together. It's ideal if you have a track for individuals to run on, or at minimum a flat surface. However, it's not really going to cost much to run. You just need the space to run, as well as a way to time the individuals. A key component to this test is that they should be able to complete the test within 12 to 15 minutes. This is important because it diminishes the potential that the anaerobic metabolic systems are contributing to that effort. If someone were unable to run 1.5 miles in under 15 minutes, then this is probably not the best test for them, and the Rockport 1 mile walk test may be a better option. Now, there are a few groups of individuals that this test isn't perfectly accurate for. Generally, it underestimates the VO2 max in children, and it will overestimate the VO2 max in competitive runners or individuals who walk. Again, if you can't go the full 12 minutes or run 1.5 miles, then you should be doing the Rockport walk test. For competitive runners, they would be better served to complete a lab test using a metabolic cart. As has been mentioned before, there is a linear relation between the speed at which someone walks or runs and the oxygen uptake of that individual. What you see graphed here is the speed of someone running between 5.2 miles per hour and 9.7 miles per hour. The units on the graph are in meters per minute. So again, you could do that conversion in this case using your conversion factor. On the y-axis, we have the person's oxygen uptake, or their VO2, which is in milliliters per kilogram per minute. And you notice that we have a linear increase in the oxygen consumption as the speed is increased. It is based on this principle that we're actually able to estimate individuals' VO2 maxes whenever we ask them to run a sub-maximal workload. Knowing that the 12-minute pace or the 1.5 mile pace is a sub-maximal pace, in the equation, it extrapolates the VO2 value that would be someone's maximal value based on the sub-maximal intensity. Now, I like this graph because it highlights a really important concept, that when you're doing this field testing or even lab testing, and you're trying to assess for someone's cardiorespiratory fitness by assessing their VO2 max, that test should really take about 12 to 15 minutes whenever you're doing walking or running. And the reason really has to do with how the metabolic systems are working to provide the ATP for that activity. If the activity is shorter than this, you'll notice on the graph that you have a large contribution of anaerobic metabolism. Well, that doesn't tell us about your oxidative metabolism, which is what we're trying to assess in this case. So in order to try and rule out as much of the anaerobic metabolism as possible, as well as prevent fatigue from being a contributing factor, then we need to have a test that's somewhere between, you could roughly say 10 to 15 minutes, most ideally between 12 and 15 minutes. If we want to truly isolate as much as possible, we know we can't do that exclusively, but as much as possible assessing aerobic metabolism. Now, we've already pointed out that for children, their VO2 max would be underestimated whenever they complete the 12-minute run or the 1.5 mile run test. Another test that is commonly used in children under the age of 18 is the PACER test, which stands for Progressive Aerobic Cardiovascular Endurance Run. This is a 20-meter progressive shuttle run. It begins at a pace of 5.3 miles per hour and increases at 0.3 mile per hour intervals for each level. And then the cardiovascular fitness is based on the number of 20-meter laps the individual is able to complete. Some of you may be more familiar with this test as being called the BEEP test, which has been commonly used in gym classes and for sporting events. It's also part of the FitnessGram testing battery for children, which is a culmination of many tests to assess for their fitness. Another common at-home test is the Modified Canadian Aerobic Fitness Test. This is a really popular test for individuals to do in their home. All you need is a staircase, and you measure to see whether or not your stairs are 16 inches or 8 inches. And based on the height of your stairs, you're able to calculate your results. It is also a 3-minute stepping test similar to the Queen's College Step Test, and it's also a sub-maximal test. So when the person reaches 85% of their age predicted heart rate max, you would ask them to stop the test. The stage progression is based on the person's heart rate responses as they're doing the stepping. You'll notice for the individual on the right, he would use 3 full steps, so the floor plus 2 steps. And he would step up left foot, right foot, and then go down. Now, in order to calculate what his VO2 would be, it would be dependent on what stage he made it to. Each stage has a different stepping cadence, and it's different for men and for women. Heart rate responses need to be monitored throughout the test, and once someone reaches 85% of their heart rate max, you would ask them to stop the test.